Hey, welcome to Econ 261, Introduction to Statistics 1. Today we'll be discussing Chapter 1, Defining and Collecting Data. So the objectives for this chapter is to understand the issues that arise when defining variables. So we're going to see how you're going to define variables. And there are some issues that are going to come up when we're defining variables. You should, at the end of this chapter, you should know how to define variables, and we can see there are different ways to do it. You should be able to understand the different measurement scales. So we're going to talk about those measurement scales and the difference between them. We will talk about how to collect data. We will discuss the how to identify different ways to collect a sample. We'll talk about to understand the issues involved in data preparation. So once you have your data, how you're going to prepare, and there are issues when you're preparing the data. And finally, we will talk about the different types of errors that are out there and what you can do to minimize those errors. So at the end of this chapter, you should have a very good idea about all of these objectives. Okay, so let's start by classifying variables by type. So what is a variable to begin with? Basically, a variable is a characteristic or property of an item or an individual. So for example, if I ask you what color is your hair, so that would be a characteristic that about your hair. So that's what a variable is. So you can classify all those variables by basically by two different types of type. One is categorical, which is also called qualitative, which means they have categories. So do you go to school? Yes, no. So you either go to school, that's one category, you don't go to school, that's a different category. Or you can classify also those variables based on numerical, which also is called quantitative. And basically, those are variables that represent uh, values that represent are counted or measured in quantity. That could be discrete if you have a counting process, or it could be continuous if you have a measuring process. Let's take a look at some examples to help us clarify that. So look at the first question. It says, do you have a Facebook profile? So you have two categories. You can answer yes or you can say no. There is no other choice. You can either say yes or no. You could add a third category and that will be okay, but will still be categorical. You say yes, no, maybe. But again, those are those different categories and you cannot deviate from those categories. The second one says, how many text messages have you sent in the past 3 days? This will be obviously numerical because you you have a number, but it is discrete. Why is it called discrete? Because you are trying to count the variables. So on this day, how many messages? You are counting how many messages have you sent in the past 3 days. And you can set any number between 0 and a million or whatever that is, or whatever number it is, right? Uh, the second question, it says, how long did the mobile app update? How long did the mobile app update take to download? This one will be obviously numerical, but it's continuous. And the reason is because you're trying to measure the time to take to download. So that is the difference between discrete and continuous. One, you are trying to count, the other one, you're trying to measure. Okay, so to clarify a little bit more, let's take a look at this slide. One thing we need to remember is that all variables are either numerical or categorical, right? So either they have a category or they have a number. Numerical represents data that can be counted or measured. Remember, you can either try to count or measure those numbers. Categorical variables whose data represents categories. So numerical data can be discrete, which is data arising from counting processes, or continuous, which is data that arises from measuring process. One thing that is important to know is that the same data that can be numerical in one process can be categorical in another process. So that's something you need to keep in mind. For example, you can say, do you have one or two children? Or you can, and then you could have it as numerical, but it could be a categorical too. Do you have a one or two children, so you can have a category of one children or you can have a category of two children. So once again, it all depends how you need to use the data, that you can have it as categorical or numerical. So don't think about once something is categorical, it's there and it cannot be moved to numerical. Measurement scales define the ordering of values and determines if difference among pairs of values for a variable are equivalent. So on this one, we can see here a nominal scale, right? And you can, what you're doing here, you're classifying the data into distinct categories in which no ranking is implied. Again, do you have a Facebook profile? Yes, no, right? Do you have a type of investment? Yes, it's growth, value, or other. So what is important, remember this, that in a nominal scales, there is no ranking implied. So if you have a Facebook profile, it doesn't mean that you're better than a person that doesn't have a Facebook profile. Now, in an ordinal scale, and think about ordinal comes from the word order, so that means they're ranked in order. So classify data into distinct categories in which ranking is implied. So, for example, what's your student designation? Oh, I'm a senior. Obviously, that means you are closer to graduating, so you have a higher standard than someone is a freshman. And usually, seniors have the first pick to choose what classes they want to take, and they have some advantages because some ranking is implied. Another example is product satisfaction, right? Very satisfied. That means you are happy with the product, or very unsatisfied, which will be a lower ranking because the product didn't meet your needs. Uh, Grades. Uh, you get an A, that means you did really good on the class. You got an F, that means you failed the class. So again, ordinal comes from the word order. Order means that there is a ranking implied. So just keep that in mind when you're talking about measurement scales. If numerical variable has a ratio scale, then you can say those variables are interchangeable. So for example, you can say that 20 sodas are twice as much as 10 sodas. Or you can also say that 10 sodas is half as much as 20 sodas. So when we talk about ratio scales, you have to keep in mind that you do have that interchangeability. And that is an order in which the difference between the measurement is as meaningful quantity as the measurements have a true 0 point. So you will have, for example, you have 0 sodas, or you can have 10 sodas, which is half as much as 20 sodas. Now, in an interval scale, there is the difference between measurement is a meaningful quantity, but the measurement does not have a true 0 point. So one example will be the temperature. So even though we have a 0, you can have, oh, the temperature for today is 0 degrees. That is not an absolute 0. That means there is no temperature, right? Which no one has been able to produce a 0 degrees temperature, meaning there is no temperature. And same thing, you cannot say that 2 degrees Fahrenheit is twice as much as 1 degree Fahrenheit, because that is not the case. So just keep that in mind when talking about interval scale and ratio scale. So ratio scale is interchangeable, while interval scale is not. Here we have some examples. So the first one, the temperatures, that would be an interval because again, there is no true 0. A standardized exam score, that's also an interval. So you cannot say somebody who scored 350 on an ACT score get half the score of somebody who scored 700 because of those interval. On the other way, somebody who says, you know what, um, he is 6 feet tall, could you say is twice as big as somebody who's 3 feet tall? And same thing with the weights, the age, and the salary. So just remember that when you're talking about ratios, you can interchange one for the other. They do have a true 0. When you talk about intervals, there is no interchangeability, and also there is no true 0. Just to keep those two things in mind when defining those ratio scales. Let's talk about what population is. So population contains all the items or individuals of interest that you seek to study. So for example, if you want to study something at TMCC, you can say, well, we have 12,000 students. So your population will be 12,000 students. Now, if you want to survey 12,000 students, it's going to take you a long time. So you may want to grab a sample. And a sample is only a small portion of the population of interest. So out of the 12,000 students that you have at TNCC, you can say, you know what, I'm just going to interview 1,000 students, right? So that will be your sample. So here in this slide, we do have a population size of 40. You can see there are 40 squares, and you want to pick a sample size of 4. So you pick up 4 random squares from this population. So collecting data via sample is sometimes convenient to do it because it's less time consuming. Imagine if you had to interview all 12,000 students at TMCC, that would be very difficult if possible because not everybody goes to school, or some people do it online, some people might not reply. So you may just want to pick up a sample. So it saves you time, right? It also saves you money because you don't have to make this huge survey. You might not have to hire people to help you with the survey. All of those things will play into effect. And finally, it's less cumbersome or more practical than analyzing the entire population. So if you have to analyze 12,000 students, will be a lot of, you will have to find a lot of different ways to try to do that. What is parameter or a statistic? So a population parameter, basically what we're saying here is when we're summarizing the value or a specific variable for a population. So we do have the population, and then you are trying to summarize the value for that entire population. A sample statistic, on the other hand, summarizes the value of a specific variable for a sample data. So you do have your sample data, and basically you are summarizing the values of that specific variable. And there are different ways to capturing data. You can capture data by generating ongoing business activities, by distributing data that has been compiled for another organization or individual, by doing surveys, conducting a design experiment and recording the outcomes, or by conducting an observational study and recording the results. So let's talk about each one of those. An example from data collected from ongoing business activity will be when you go to Google and Google tells you, oh, these are your surveys. Or if you watch Netflix, Netflix will collect the data of the movies or shows that you watch so they can recommend shows for you. Anyway, every time a business is doing, a business has an activity and they do collect data, that's an example of ongoing business activities. Here are some examples of data distributed by an organization or individual. Example, financial data or company provided by investment services, industry or market data from market research firms and trade associations, stock prices, weather conditions, and sports statistics in daily newspapers. So again, all of this data is already being collected and now it's been distributed by another organization or by an individual. Here we are talking about example of survey data. Anyway, if you conduct a survey, so you want to stand there at the outside of a building and you want to ask people questions, that would be a survey, right? And so that would be an example of a survey data. We get those political campaigns that are collected and then they distribute it. So again, those will be example of survey data. Here we're talking about examples of data from a design experiment, so consumer testing of different versions of a product to help determine which product should be pursued further, material testing to determine which suppliers' materials should be used in a product. All of those are examples of data from a design experiment. Basically, they did the experiment and then they produce the data. Here we have example of data collected from observational studies. So basically, you want to do a study, you observe, and then you distribute the data. An example will be market researchers utilizing focus groups to elicit unstructured responses to open-ended questions. So they're up there on market research doing those questions, and then they distribute the data. And the observational studies and design experiments have a common objective, right? Both are attempting to quantify the effect that a process change, which is also called a treatment, has on a variable interest. In an observational study, there is no direct control over which items receive the treatment. So this is very important. You're just observing, right? So maybe uh, you you just want to observe how many students got an A. So you just do a survey and ask them how many people got an A on this class. On this class, you don't have control over which items receive the treatment or which, who, in this case, which students got the A. You're just observing who got the A. Now, in a designated experiment, there is direct control over which item received the treatment. So one thing that we can see, for example, is that we give somebody the COVID shot vaccine, and then we see how they respond. So you have direct control of who received the treatment, and then you compare it to somebody who didn't receive the treatment, and that's how you do your study. When we talk about sources of data, they could be either primary or secondary. Primary will be if the data is collected by one using one of the data analysis from a political survey, data collected from an experiment, or observed data. Now, the secondary sources will be the person performing data analysis is not the data collector. So if you are collecting the data, then you are the primary source. If you are using the data for somebody else, then you're a secondary source. The frame is a complete or partial listing of the items that can make up the population from which the sample will be selected. In a non-probability sample, you select the items or individuals without knowing their probability of selection. So on a probability sample, you select items based on non-probabilities of selections. So you can either say, you know what, I'm gonna use this frame, which was the complete sort listing that make up the population, right? And then you can say, yeah, I'm gonna use a non-probability sample, which basically you don't know the probabilities of selection. So you have a population and you wanna select, you know what, I wanna find out how many people have black hair. So you don't know what the probabilities are. And that would be a non-probability selection. Here we have the samples, right? We have the non-probability samples, which could be judgments or convenience, and then you have your probability samples, which could be simple, random, it could be systematic, stratified, or cluster. So what do we mean by this? Let's talk about the non-probability sample. In a non-probability sample, items included are chosen without regard of the probability of occurrence. In a convenience sample, items are selected based only on the fact that they are easy, inexpensive, or convenient to sample. In a judgment sample, you get the opinion of pre-selected experts in the subject matter. So you go to the experts and you sample them. You ask them questions to try to get their opinion. On a probability sample, items in the sample are chosen on the basis of known probabilities. So that probability could be simple random, could be systematic, stratified, or cluster. So what is a simple random sample? Basically, it's a sample where every individual or item from the frame has equal chance of being selected. What is important here, right, is that every item in the population has the same opportunity of being picked as anybody else. So let's say we have 12,000 students at TMCC. You want to do a simple random sample. Every one of those 12,000 students should have the same probability of being picked. So you cannot choose somebody else over another one. Now, selection may be with replacement, where the selected individual is returned to frame for possible reselection, or without replacement. So on the case of you select those 12,000 students, right, everybody has the same opportunity of being picked. So you pick one person to ask them a question, you do, and then you put their name back on the pool. and that person could potentially be picked again. So that will be with replacement. Without replacement means once you pick that person, you remove them from the pool, so you cannot ask in the same. You cannot ask the person the question again. Samples obtained from table of random numbers or computers and random number generators. So what does this mean? Here we have, for example, a simple random sample using a random number table. Uh, so imagine that you have a population on this example of 850 items. It looks like there are 180, 850 people, right? And you can use a random number table. If you look at your book on Appendix E, page 737, you will get a random number table. Let me show you what it looks like. Here is a random number table from the textbook. So in this case, right, we do have 850 people, and you're assigning the numbers from 001 to 850. Well, that means you will need 3 digits for each person. For each person, you're assigning a number, right? So the first person will be 492. The second person will be 108. The third person will be 192. The fourth person will be 435, and so on and so forth. Um, so that's how you get here. You got the 492. So the first item from the random sample will be 492. So that will be like you're picking that person 492. The second will be 808, like it's in here. On this case, you can see we have 892, which is above 850. So we ignore this one and we move on to the next one, which is 435. So that's how you do the random number table. Let's say that you only have 100 people or 99 people, so you only need 2 digits. So in this case, the first one will be 49, the second one will be 28, the third one will be 08, and so on and so forth. So once again, you can use the random number table by picking the number of digits that you need, and then you grouping them. Also, you don't have to start on 492. You can say, I'm going to start at 098. So in this case, 098 will be your first one, 932 will be your second one, and 997 will be your third one, and so on and so forth. What is systematic sample? Systematic sample is when you decide what sample you're going to choose, and then you divide the frame into n, which is your entire populations, and you group them into a different amount of groups that you choose. So to figure out how many do you need, you divide your entire population by the sample size, and then you randomly select an individual for the first group. So take a look at this one, right? We do have 40, which is our entire population. We want to get a sample of 4. So 40 divided by 4 is 10. So in this case, we will have 10 groups, and then you randomly select the first group, and in this case, we can see the cells in red. Finally, the probability sample, the stratified sample. In this case, you divide the population into 2 or more groups, which is called strata, and then you base those 2 groups on some characteristics, right? Going back to the prior example, people who has Facebook, people who doesn't. So a simple random sample is selected from each subgroup, which sample size proportionally through strata sizes. So you make sure that those selection is based on the proportion of the strata. And the sample from subgroups are combined into one. So once you pull the subgroups, you combine all of those into one. And this is a common technique when sampling population of voters, stratifying across racial or social economic lines. So you ask them, are you Republican, are you Democrat? Then you grab those samples, you mix them, and then you combine them into one group to conduct your survey. And then you can have the cluster sample, which is basically you have your population and you divide it into several clusters, each representative of the population. A simple random sample of cluster is selected. Remember how we did the sample random selection? Kind of the same thing after you do the clusters. All items in the selected cluster can be used, or items can be chosen from a cluster using another probability or sampling technique. And a common application of cluster sample involves electing exit polls where certain election districts are selected as sample. So you notice, right, when there is an election around 8, 9 o'clock, somebody, NBC announced that they predict that somebody in so is going to win this election for this. And they don't go and check every poll. They just select some specific ones, and then they, based on that, they do their decision. Here, take a look at this example, right? You have the population, you divide it into 16 clusters, right? And then you randomly select the clusters that you're going to sample. Let's compare the different sampling methods, right? On a simple random sample and systematic sample is really easy to use. You see that we have the table. You can use Excel or other program like that to help you with numbers, right? But it might need to be good representation of the population's underlying characteristics. So some population, has different characteristics than others. But when you're doing this sample random selection, you are you might miss some of the population's underlying characteristics. So let's say that you are sampling the students here at TMCC, and for let's say this year we do have a larger amount of freshmen, and because you're using the sample random selection, you will have under a population of people that is in their second year of college here at TMCC not being represented properly. In the stratified sample, the advantage of that is that it ensures representation of individuals across the entire population. So remember how you divide that into clusters. So people who's on their first year at TNCC, people who's on their second year at TNCC. So because you're stratifying, you get better representation from both clusters, from both from the individuals across the entire population. And the cluster sample is more cost effective because it's a lot easier. You cluster the population into different groups, and then you sample only a specific groups. Unfortunately, it's less efficient because you need a larger sample to acquire the same level of precision. Let's talk about data cleaning, and this is very important because you get your data, and then you ask yourself how accurate is this data. So you have to go through the data cleaning process to correct irregularities in the data. For example, you can have invalid variables. So you can have non-numerical data for numerical variables. So you're asking how many kids do you have, and somebody, instead of giving the number 2, they write the letters 2. So you could have invalid categories variables for a categorical variable. So you can ask people, do you have a Facebook account? And instead of saying yes or no, they could say, I'm thinking about it, and that's not a category. Numerical values outside a defined range. So you can give you a number that is outside of what you are looking for. You can also have coding errors, which are inconsistent categorical values. You can have an inconsistent case for categorical values, or you have extraneous characters. You can also have data integration errors. So if you have your data, then you're trying to send it from one format to another. You can have redundant columns, you can have duplicate rows, you can have different columns length, and you can run into different units of measurements of scales for numerical variables. So, for example, you ask, what the temperature is like, and somebody might be answering in Celsius. Somebody else might be answering on Fahrenheit degrees. So you can have those issues when you have the data. So unfortunately, the data cleaning process cannot be fully automated. And ideally, you will want to have a program that cleans your data and make sure everything is good. But by nature, that's not something that the program can do in itself. So a lot of times you're going to have to manually do it yourself. Now, for this class, what we're doing here, you don't have to worry about it. Everything is fully everything here has already been cleaned. So all the data that we're giving you for problems and for the exams is already been cleaned. So you don't have to worry about cleaning any data. But that's something you just kind of have to keep in mind that when you're doing surveys out there that you might have to clean your data. Very important also, once you're doing the data cleaning, keep a copy of the original data. That way, if you ever need to go back and look into it, you know how to get to it. So how you clean invalid variables that can be semi-automated. So invalid variables can be identified by simple scanning techniques. Non-numerical entries for numerical variables, those are easy to spot. Values for categories that don't match a predefined category also will be really easy to match. Values for numerical variables outside a predefined explicit range. Again, some of those can be semi-automated, and you can use some of the features that exist in Excels or the JMP or the Minitab that can help you with that. Let's take a look at some of those coding errors. Copy and paste of data import can result in poor recording or entry of data. So sometimes it's very convenient just to copy and paste, but some of the data can be misplaced or mismanipulated during the process. And then you have the categorical variables, right? So you ask people, what is your gender? And you ask them for F for female or M for male. But people can write female instead of F. That's something really simple. You can just correct it yourself. But they could give you invalid data. Maybe they give you a city like New York, and then you don't know, if it's male or female, male or female. And then you have correctable software tolerated. That's that's M instead of capital M. They just write M, so the software does not recognize the entry. Also, sometimes might be difficult to the eye because there could be some either blank before the entry or after the entry, and the software does not recognize it because it's not just the letter F, but it's also a blank after or before that you really can't see. So those ones could be hard to spot. The data integrating errors from combining two different computerized data sources. So for example, you export data and you export it as a CSV or a comma separated values, but then you need to transfer it to Excel format that is different. Some of that data can be difficult to manipulate. So those are data integrating errors that requires time-consuming manual effort. Uh, Variable names or definitions may differ. You can have duplicate rows. You can have different units of measurement. All of those could cause those data integration errors. Also, data can be formatted and or encoded in more than one way. That's another issue that we have. We see some electronic formats that are more readable, readily usable than others. You can have different encodings that can impact the precision of the numerical variables and can also impact data compatibility. And as you identify and choose sources of data, you need to consider and deal with those issues. So that's something you will need to keep in mind. So when you want to consider two or more groups, you can arrange as either or a stack or unstacked data. So what is unstacked data? is when you create separated numerical variables for different groups. So you have your genders, your location, and stack data is when you create a single column for the variables of interest and create additional columns for the potential grouping variables. So again, you have your data and you want to break it up into different groups, and you can either stack it or unstack it. After collection is often helpful to recode some variables. So you're going to see that you collected your data and you might have to do some recoding. So recoding means a variable can either supplement or replace the original variable. The recording of a categorical variable involves redefining the categories. So maybe you say, well, this category is not what I was looking for. So you may have to record that. And when recording, be sure that the new categories are mutually exclusive, and that means they do not overlap, right? And are collectively exhaustive, cover all possible values. So, for example, you say, well, I'm looking for people that from the ages from 10 to 19, 20 to 29. So you gotta make sure that you don't do 10 to 20, 20 to 10, because now if you are 20 years old, you say, well, do I go into the category of 10 to 20 or do I go into the category of 20 to 30? So you might gotta make sure that those do not overlap. And also it's exhaustive. You know, what if I am 40 years old? Then I don't fit into any of those categories. So that's what we mean by those. Also, make sure that, you know, if you're doing a survey, you evaluate how what the survey is. So first, what is the purpose of the survey? Is based on probability sample. What about coverage errors? Do you have the appropriate frame? Remember the frame that we talked about it? Do you have that appropriate frame? Non-response error, follow up. Some people, you know, might not wanna answer your survey. You might have a measurement error. So good questions elicit good responses. And finally, you can have a sampling error, which you always are going to have sampling errors. Okay, so talking about errors, you can have a coverage error or selection bias. And this one exists when some groups are excluded from the frame and have no chance of being selected. So, for example, let's say, you know, I want to survey the students at TMCC, and then you say, you know, you start, what is your age? And then you mark it from 18 to 21, from 22 to 25, and 25 to 30, 30 to 40, and then you go 41 to 50, and 51 and up, right? But you forgot that could be students that are younger than 18. So that will be a coverage error because you are excluding anybody under the age of 18. You can also have non-response error or bias. So people who might not want to answer your survey or might answer different than what they really think because they don't want to tell you that how they really feel. So you might want to ask them, oh, what was your GPA? And they might be embarrassed to say, oh, my GPA was 1.5. So it's, oh yeah, my GPA was 3.0. So that would be a bias because they don't want to tell you what the real GPA is. Sampling error means the variation from sample to sample will always exist. And we'll discuss that later in another chapters about the sampling error. But just remember that you're always going to have sampling errors. And finally, you can have measurement errors, which is due to weaknesses in questions, design, or response error. So coverage error, excluded from the frame. Non-response errors, follow up on non-responses. Sampling error, random difference from sample to sample. And measurement error, bad or leading questions. So let's say you want people to tell you that they really like TMCC, and you ask them a question. TMCC is a great college. What do you like? So you're already leading with the question which you want them to answer. So that would be a measurement error. Let's talk about ethical issues about survey, and this is somewhat common in in advertisement. So a lot of times you see a commercial say 9 out of 10 dentists recommend this toothpaste. What they don't tell you is that those 9 doctors that recommended the toothpaste, they actually work for the toothpaste manufacturer. So that could be an ethical issue because they really not disclosing that. So coverage errors and non-response errors can be leveraged by survey designers to purposely bias survey results. That would be one case. Sampling errors can be ethical issue if the findings are purposely not reported with the associated margin of error. So you do have a margin of error, but you don't disclose that. So measurement errors can be an ethical issue if survey sponsor chooses leading questions. So again, you want people to answer in a certain way, so you frame the question to answer that way. Interviewer purposely lead respondents in a particular direction, and finally, respondents willfully provide false information, like in the example I mentioned earlier, somebody who has a lower GPA and don't want to disclose that. Okay, that's plenty for today. So remember, in this chapter, we discussed the understanding issues that arise when defining variables. We talk about how to define variables. You should have a good understanding of the different measurements of scales. You should know how to collect data. You should know how to identify different ways to collect a sample, understanding the issues involved in data preparation, and finally, the different types of survey errors. All right, that will conclude our chapter 1.